Dear students, the next topic of Module 4, which we are going to study under the chapter Inter-Process Communication, is the semaphore. It is very important inter-process communication method, and here what happens is, let us see what is semaphore first. A semaphore is a counter. Counter is nothing but an integer value. So a semaphore is a counter used to provide access to a shared data object for multiple process. It means uh, some data is there which can be shared among so many processes. So semaphore will act as a counter and it will monitor all the processes who are accessing the data object. Okay, so it monitors all the processes who all are accessing the shared data object, and it will monitor in, or it will allocate the data object in such a way that the clashes should not happen among the processes. So all the processes need to be synchronized. So how it handles the semaphore, it follows some steps. Let us see those steps. To obtain a shared resource, a process needs to do the following. What all things it need to do? First, test the semaphore that controls the resource. So process will first contact the semaphore. What is the value of the semaphore? As I said that semaphore is nothing but it is an integer value which will act as a counter for the resource. So the process which want to access the resource, first it will contact the semaphore and it will test it, and it will, the semaphore which controls the resource, and if the value of semaphore is positive, the process can use the resource. It can, the process will be allowed to access the resource only if the semaphore value is positive. In this case, the process decrements the semaphore value by 1, indicating that it has used 1 unit of resource. It means if a process is allowed to access the resource, then the value of semaphore will be decremented by 1, and it indicates that say a process has accessed that semaphore. Otherwise, if the value of the semaphore 0, in another case, suppose if the value of the semaphore is positive, this will happen. If the value of the semaphore is 0, then what will happen? If the value of the semaphore is 0, then process will go to sleep until the semaphore value is greater than 0. So process will goes to sleep until the semaphore value is greater than 1. You remember, a process can access the semaphore a process can access the resource only if its semaphore value is greater than 0. If it is 0, means all units of the resources are allocated to different process. Now there is no unit of the semaphore is free. So till any unit of the resource is free, the new process has to wait and it has to go for sleep. So when the process wakes up, it returns to step 1. When the process wakes up, it returns to step 1, means again it will follow the step 1, it will test the semaphore. If it is positive, again it will access the resource. Otherwise, if it is 0, then again it will go to sleep. And this is what will happen. So when a process is done with a shared resource that is controlled by a semaphore, the semaphore value is incremented by 1. Once the process has finished the work with the resource, then process will release that resource, and then the semaphore value will be incremented by 1. If any other processes uh, sleep asleep waiting for the semaphore, they are awakened. Or any other process who are sleeping and they are waiting for the process, they will awaken and they will try to access the semaphore. A common form of semaphore is called a binary semaphore. A binary semaphore means only one unit of the resource will be there. So if the resource is free to be allocated to a process, then the semaphore value will be 1. If resource is already allocated to another process, then its value will be semaphore value will be 0. So the value of semaphore for the binary semaphore, it can be only 0 or 1. So that's why it is called binary semaphore. So in general, however, a semaphore can be initialized to any positive value with the value indicating how many units of the shared resource are available for sharing. Now suppose a resource has the 5 units, then its a semaphore value will be 5. The kernel maintains a semaphore ID underscore data DS structure for each semaphore set. The kernel maintains a data structure same ACM ID underscore DS for each semaphore set. Let us see what all things will be there under this structure. So struct same ID underscore DS, struct IPC underscore PERM, semaphore ACM underscore PERM, and unsigned short ACM underscore NSEMS, time underscore T ACM underscore O time, and time underscore T ACM underscore C time. So here same underscore O time is the last semaphore operation time, and same underscore C time is the last change time, and same underscore N same number of semaphores in the set, and all these things data will be available in the semaphore ID underscore DS. Now each semaphore is represented by any anonymous structure containing at least the following members. So every semaphore will be represented with at least the following data, like struct unsigned short same value, semaphore value always greater or equal to 0, PID underscore T, semaphore PID, PID for last operation, unsigned short same